Okay, so first example I want to do on method of moments is the gamma. Parameters are alpha and theta, right? And this is like the best example. This is the example of a distribution where we use method of moments. Why, you may be asking? If you really want to, you can try using maximum likelihood estimation for this. It's hard. I would just look up maximum likelihood estimation for a gamma distribution, and I certainly can't follow along with how they go about it. So, therefore, we use method of moments instead because it's computationally much less heavy, right? So what we have is that X follows a gamma distribution with alpha and theta as its parameters, right? This means that the expected value of X is equal to alpha theta, variance of X is equal to alpha theta squared, right? So then we have, using method of moments, we set sum xi's over n is equal to alpha times theta, theoretical expected value, and 1 over n sum of xi minus x bar quantity squared is equal to alpha theta squared, right? The theoretical variance. Notice we used variance in this case just because the variance of a gamma distribution happens to be a bit easier to write out than the second moment, but either one would get us the same answer. So if you divide right hand side of the second equation by right hand side of the first equation, that gets us theta is equal to, now left hand side of the second equation divided by the right hand side of the first equation. Left hand side of the first equation. I think I misspoke there. Right, and now we write, because this is an estimate for our parameter, we write theta hat method of moments, because that's what we use to find this, and that's equal to this, which looks very complicated, right? Except you have to realize that everything on the right-hand side is just something that we know because we took our sample, right? So, top is just the variance of our sample. Notice we have 1 over n instead of 1 over n minus 1. That's just how we do this for method of moments. Now, bottom is sample mean. So even though it doesn't look the prettiest, that's pretty straightforward, actually. And now, to solve for alpha, we can plug what we just found back in to equation 1. Right? And we know theta hat is that, so 1 over n sum of xi's equals alpha times 1 over n sum of xi minus x bar quantity squared, 1 over n sum of xi. We can bring all this over to the left side, and we get 1 over n sum of xi squared over 1 over n sum of xi minus x bar squared is equal to alpha hat method of moments. right? So this gamma distribution, which if we used maximum likelihood estimation would have taken us a very long time, ended up not being much work at all.